because there's a lot of misinformation and confusion out there about what even the most basic systems do, how they work, and identifying problems, okay, what the actual reason is for problems. Thought I'd take the time to explain how the charging system actually works on the car. The starting system comes into it, sort of. Anyway, let's first discuss the role of the battery, because it seems like no one understands why the battery's there. Everybody knows that to start a car you need a battery. That's true. But the thing is, the battery provides a lot of current for a short amount of time. That's what it's good at doing. It's good at doing two things. One, a low amount of current for a long period of time, or a lot of current for a short period of time. And that is designed to get the engine started in the first place, and to provide power when the engine's not actually running. Once the engine's running, there's two different states with the charging system and battery systems. There's not running, which means you're drawing from the battery and discharging the battery. Once the car is actually started up and running, then basically you enter a different state, which is the battery's basically just there to help smooth out, spikes and things like that. The alternator is designed to charge at a voltage, or designed to output a voltage higher than the voltage of the battery. The static voltage of the battery, if I just change my multimeter leads around, it's very hard to do this with one hand, but we put this lead here, it's showing almost 13 volts. That is basically the fully charged voltage of this battery. So anyway, the first thing I'm going to do is show you guys what the voltage of the battery, or charging system is, I should say, when the engine's running. So I'm going to do that now, and then I'm going to explain more stuff. So now that this engine's running, the thing to notice is that the voltage is around 14 volts, or 13.96, it depends on. That is because the alternator is outputting a voltage higher than the desired charged voltage of the battery. You have to put out a slightly higher voltage than that which you wish to charge to. And there's also another reason, and the other reason is we desire to power everything on the car with the alternator. So when the car's running, what's actually happening, alright? What's actually happening is the alternator's powering everything on the car. That's why alternators have a large current capacity. This alternator has a current capacity of 90 amps, okay? That's what it says on the side of this alternator case. Who am I to argue with it? So 13.95. So when we switch a load on, like the headlights for example, on high beam, on, the alternator puts out a voltage to supply those headlights with power. Now if I rev the engine up slightly and get my hand on that throttle, it's hot because I've just driven this car. But anyway, voltage would go up slightly, not very much, but anyway, that is the role of the charging system. The battery's role is to start the car up in the first place and to smooth out, it helps smooth out the voltage, any ripples and all that sort of stuff. Its other function is that if you draw a ridiculous amount of current while you're driving the car, the battery is there as a reserve to make up the difference. Like, I guess you could say a capacitor, for example. It's going to allow more than the alternator's maximum output current to be drawn from the system at any one time. Let me turn the car off and let me explain more stuff. You can see that I've just turned the car off and the voltage is slowly going down. That's normal. That's, basically what you'd expect. It'll settle at just under 13 volts. This is just what it is because I've just had it running, and the alternator puts out around 14 volts. The maximum, it tells you, okay, in the workshop manual what the maximum and minimum output voltages of the alternator should be. So we've got the battery that starts up the car, providing all that current, smoothing out the output of the alternator slightly, and making up the difference if the alternator can't keep up. I don't know what you would be running, but say if you had a fridge, an inverter, blah blah blah, whatever, okay? You know, you'd need more than, maybe you'd meet or exceed the alternator's maximum. Generally with fuel injected cars, they have an alternator large enough that you would never ever meet or exceed the value of that alternator. Subwoofer amps can, and that's a different subject, and I'm not going to discuss it. Especially if you don't know how to, set the subwoofer up correctly and you like to clip the amp too much. You might start to drag a lot more current than you should be. Anyway, if you draw a current at a voltage through a wire, and that wire has resistance in it. Resistance is like a roadblock in the way of the electrons flowing through the cable. For those electrons to get over that roadblock or roadblocks, I look at 1 ohm as a roadblock. I mean, the more ohms you've got, the more roadblocks you've got in place, right? Okay, so you start to create a byproduct of the electrons trying to get through the higher resistance, which is heat. Okay? So, what happens when you have a higher resistance than you should? Now, the resistance you should have in any connection to do with the starting and charging system is the minimum your multimeter will read. Now, allow me to show you or demonstrate what that minimum is. Let's unplug this lead. Okay, let's unplug this. Let's go over to ohms resistance. Let's plug that in there. That's the native resistance of the meter. It goes to 0 basically. By the time you got both leads hooked up, you might be showing 0.1, 0.2 ohms, right? Whatever. But the idea is to get every connection between the battery, the alternator and the starter motor at 0 ohms or as close to as possible. And the reason why is because any resistance is a loss of current. So you might have your 13 volts at your battery, but if you've got a resistance, you can't draw whatever that battery is capable of, which is 540 cold cranking amps. Okay, so you can drag that much current for a short amount of time. So that heat will do damage. Now, let me move this out of the way. This damage is going to manifest as discoloration of wires and stuff. Now this is dirty, it's probably not going to show up very well. You can see this is kind of baked. This alternator output cable is baked. It's gotten hot because between the crimp lug and the cable, let me zoom in a bit, there's resistance that shouldn't be there. The tape's all black, even the actual wire is black. I've actually taped that up, so it's not a very good example. But if I move over to this dark green VS, I have never touched this, and maybe it's going to be more obvious. This is a different alternator, by the way, it's been replaced. Now, the light here is not very good. Where are we? But you can see this has sustained a little bit of heat. It's discoloured. Stupid camera. You can see it's sustained heat. You can see that, peel off this tape maybe, I don't know if I can. This is going to be replaced anyway because this is crap, but let's actually pause this, peel off the tape and show you guys what I can see. So where I've pulled off this tape, you can actually see the cable's black. Now I'm not sure if that's from the dye from this bit of tape, but this is discoloured, the insulation's hard, and if I go from the above shot, you can see that that lug has been hot. There's been heat sustained through that lug. It wants to focus. Hello, are you there? So that lug's been hot, you just have to take my word for it. You can see there you go, you can see the cable's discoloured, the lug is kind of corroded looking. It's been really hot. So if this alternator output cable's a problem, how the hell can I figure it out? Well, the answer's in front of you. Basically, I got my trusty 77 Series 3, which is a fantastic meter. If you're going to buy a second-hand meter, buy new leads and probes, right? So what I'm going to do is set up to do this test, and then I'm going to show you guys what I'm doing and how I'm doing it, basically. So to prepare for this test, we have our meter leads completely isolated from battery and everything. We go to where the terminals are on the meter. We've got the meter leads in ammeter, position. See, common and the ammeter 10 amp there. We're going to put it in DC amps. It's very important to make sure that these are completely isolated. The reason why is because between the two probes there, it's a dead short. Ammeter is a dead short, so don't forget, if you probe between battery terminals or whatever, you're basically going to short circuit something and probably blow the fuse in the meter and blow another fuse in the car. The first thing to do to prepare for the test, apart from the meter, is start the car. The reason why is because we want the alternator to be able to produce a current at a voltage. We're going to put some loads on. We're going to put headlights on, high beam. We're going to click the rear demister. We're going to put this fan on. Okay, we're going to load. We can hear it. The alternator pitch has changed. Now what we're going to do, basically, is we're going to put this red lead on the alternator output terminal on the back of the alternator, and we're going to put this black lead on the positive terminal, because what we're trying to do is measure the current loss between the battery positive and the alternator output. That's loss, that's heat. Now sometimes if it's got quite a decent resistance like this car does, if you don't have a multimeter, you put your hand on the alternator output, it feels quite warm already. I haven't even had it running long, and the same thing applies to earths. This earth I think I've replaced. I don't, no, maybe not. I don't remember, but no, maybe not. It's getting warm, so if you don't have a meter, heat is the obvious byproduct. So if you load it up like this, the alternator's working hard. The battery's not really doing much. Battery, irrelevant. When it's running off the alternator's output. So what I'm going to do, I wish I had a tripod or an assistant right now. I am going to, because this is current, the ideal would be to get some crock clips for these fluke leads, which, yeah, but I haven't done that yet. I'm going to put this probe I'm going to put here. I'm going to try and stab that in hard so it's got a good connection. And what I'm going to do, make sure your leads don't touch your fan, because if you paid a lot of money for your leads like I did, it might make you sad. Okay, I'm going to go to my alternator output. When you do this, if you've got a really bad alternator output, you might find your headlights get brighter. I don't know if they're brighter or what, but it hasn't made a huge difference on the camera, but anyway. Now, what it's showing is 0.98 amps. There you go. Oh, fuck. Okay, if you slip, that's going to happen, right? I don't know if I've blown the fuse in the meter or what. Don't slip. But we're showing 1.1 amps. Basically, that was a demonstration of what not to do. You should have crock clips so you don't have to sleep with the multimeter probes. If I wasn't on camera, it wouldn't have happened because I'm not concentrating on the camera instead of what I'm actually doing. So I'm not going to edit that out. I'm going to leave it in for you guys to watch and laugh at and whatever. But that's too much. That's a lot of current to drop over a short amount of cable. What you should really be seeing is a very small amount of current. Now make sure that lead doesn't touch the car, because this end is connected to the battery positive. So I'm going to drop it on the ground, do the same with this lead. So if you can get a set of leads with croc clips, and these fluke leads, I bought the ones that have the plugs. They're very good, and you can get croc clips that plug straight onto this. They're really worth owning if you work on cars. So I'm going to shut this down. I'm going to explain what the fix is. Now, what has to happen is the alternator output cable has to be replaced. The reason why is because where the lug crimps onto the cable, it's got a dodgy connection. The crimp connections are great, but solder connections are better. The reason why is because a soldered connection to a lug is basically proof of everything. Water can't get in because it's soldered to between the lug and the strands of copper directly. You know, oxygen can't get in. Battery acid can't get in. Pretty much, okay? A crimp connection is not very good for a car, and the reason why is because it's not waterproof, it's not oil resistant, that kind of thing, okay? So that's where the problem starts. The problem starts simply because you've got stuff that gets in between the lug and the cable itself. That creates a resistance, and then that also creates the heat. The diagnostic procedure is basically the ammeter across the alternator output, which is quite warm actually. I'll point out that, you know, this lug is really quite warm, and you know, that's because of the resistance. The heat is being produced because of the resistance. It takes quite a lot of energy to overcome resistance. So that's why it's happening. So between here and here, you really shouldn't have much of a voltage drop, or voltage drop is fine, but I prefer to actually measure the loss in the form of amps. It shows me a more accurate picture of what I'm actually losing, because I can do calculations. I can work out what the headlights draw. So basically, amps is watts divided by volts. So if your headlight globe's 21 watts divided by 12 volts, or well, it's 13 volts or 14 volts while it's running, right? That's going to tell you what the amperage of the globe is. You can work out pretty much, losses, draw, all that sort of stuff. It's the Ohm's law, which you should Google. You should be reading it, and you should know it. I have Ohm's law printed out and beside my bed. Okay, so whatever. Because I think it's really important to know that stuff. If you've got expensive leads, don't leave them on the ground like that. So how do you fix it? Well, this car here, you got a couple of connections. This first one here, the big fat one, goes to the starter motor directly. Then we've got this one here. You can see there's a fork in it, right? There's a Y join. This is actually the alternator output, and that goes basically sort of around the front of the engine, and then it sort of snakes around up here behind the manifold to the alternator output. That's got to be replaced. That has to be bypassed. So what you're going to do, this is normally taped up. This here, right, it normally looks like this here. This is a standard setup. This is what it looks like. The white stuff, by the way, is bicarb soda to neutralize all the acid that's around here. So you're going to take all this spaghetti off, pretty much, because you don't need it anymore. You can reapply it if you wish after you've done it, right? So we're going to get our side cutters. There's two things happening here. The first is this. Get this out of the way. This goes to the alternator output, right? This cable here is spot welded to the alternator output cable under this heat shrinking, right? That's why it's got that Y joint. It's not lugged, it's spot welded. That goes to the main fuse box. That powers everything on the car. You can just see here, right? That's where this goes, to this big fuse box. So it's powering basically everything, and this also powers other stuff that this thing doesn't mention, right? So we're going to cut this. We're going to cut this off basically. Sorry if I'm zoom out a bit. This we're going to separate from the alternator output, and we're going to lug that. And then that lug is going to go to a brass battery terminal. Something like that, you know, personal preference, whatever, okay? But we're going to have a brass battery terminal, and usually you got two bolt positions, one there and one which would be on this side, and that's perfect. So what we're going to do, we're going to lug the main feed, and we're going to screw it straight down to a bolt like this. We're going to get rid of all this sheet metal crap, whatever, right? The alternator output, this, we're going to cut it through somewhere down here. We're going to get rid of it completely. We're going to bypass it totally, right? We're going to run a new cable, totally new cable, and you can basically see that it's a bit hard to see where it goes, but it goes down along the front of the engine, then it goes up somewhere. I don't have a torch and I can't be screwed actually showing you where it goes up, but just loom it so it won't interfere with the fan belt or serpentine belt, and cable tie it, definitely cable tie it. Don't just leave it hanging around, because it might foul with the belt or just cause another problem like it chafed through. If you want to, you can, you know, loom it up in that this corrugated slotted, you know, insulation. Where you would choose a wire maybe twice as thick as this. The thicker the cable, the better. You should be soldering it. You can flame solder. If you heat the side of a lug, you can flame solder the copper in. You can flame solder the lead tin solder in around the copper wire. And you have to make sure it's not going to contact anything down here. The rocker cover's plastic, but not the body of the alternator and not anything metal, obviously. They do come with this silicon type of boot, I guess you'd call it, just a protection boot. But, you know, if that's ruined, well, you can get one from the wreckers, whatever, different brands of car, it doesn't matter what brand the car is, maybe you'll find something suitable. But that's pretty much what you're going to do. You're going to have a wire with a ring lug at each end, one going to the alternator, one going to the battery positive, and this main feed, which powers everything basically, the whole car. You're going to put a lug on that, and you're going to screw it to the battery positive terminal. And while you're there, you might as well get rid of this crap, you know, buggered old earth, and put a thicker one. And if you go here, you can see that it goes to a bolt on the body, or a stud. That earths everything. Except for the engine, it earths every other system in the car. So it's absolutely vital, and it can be checked in the same way as you checked the alternator output cable. You can basically attach your ammeter, right, with the engine running, with the load going, between here and between that bolt, between that stud, right? Can't show you because everything's in the way, but you can check that, and you can actually measure it. It's showing 0 because there's no load, not much of a load being dragged. But that is important, because there's no point replacing alternator output cable if you're not going to replace the earth, which is shit. Like, look at it. It's thin, it's old, it's got a high resistance at the lug on each end, right? You know, it's discoloured. I should have replaced it years ago, except I'm replacing the car, and that's why I keep this car, partly because I can show you guys faults. If I get a car that's perfect, what would I make videos on in the first place?